All moving vehicles are subject to physical forces and energy. The larger and heavier the vehicle, the greater these physical forces become. For some vehicles, such as tankers carrying an independent load, these forces can be deadly. Perhaps tanker drivers don't need to worry quite so much about bridge strikes or gusts of winds blowing them over as drivers of high vehicles such as taut liners do. Their vehicles still have inherent dangers. As they are carrying a load which is independent to the structure of the vehicle, there is a far greater chance of the vehicle rolling over on bends and curves. When it is empty, the road tanker will operate very similar to most other vehicles on the road. However, when liquids or powders are added to the vehicle, this creates a separate force. This force can move independently of the vehicle, creating enough displacement to roll it over. Speed and angle of turn are the two key factors that create this energy. As a vehicle is driven round a bend, centrifugal force is created on the opposite side of the vehicle. This centrifugal force can be great enough to take the vehicle off its centre of gravity and roll it over. The centre of gravity is the pivotal point between the width and the height of the vehicle. As the height of the load increases, so does the height of the centre of gravity. With most vehicles, the higher the centre of gravity, the more unstable the vehicle becomes and the more likely it is to roll over. As a tanker is carrying a load that can move independently of the vehicle, the centre of gravity can be altered by the pendulum effect in the load area. This pendulum effect can be created at speeds as low as 5 miles an hour, making tankers easy to turn over even at low speeds. Control of speed and angle of turn is essential whenever driving a tanker. When driving in a straight line, all the forces of energy are going in the same direction. When a turn is made, however, a separate force created by the energy is made as it attempts to carry on going straight. As an example of this separate force, as you turn to the right, the force goes to the left. As you turn to the left, the force goes to the right. Turns such as this can create sufficient energy to roll the vehicle over. As a mathematical example of this physical force, if a vehicle had a gross weight of 44 tons, with a tare weight of 15 tons and a net weight of 29 tons, this would mean that during a turn we would have control of 15 tons of the vehicle. The independent load would have a force of 29 tons going in a different direction. Bearing in mind the poor stability that tankers offer at acute angles, this weight differential, if allowed to go uncontrolled, will roll the tanker over. Tanker manufacturers do fit safety features to tankers, such as baffles or surge plates. These help reduce the surge from the front to the rear of the vehicle, but don't reduce any surge whatsoever from the side to side of the vehicle. Modern tankers may even come equipped with features such as intelligent braking and suspension systems. Regardless of any safety features fitted to the vehicle, the key elements to a rollover will always be the same: the speed and the angle of the turn. If this is too fast, the vehicle will roll over. Other factors could of course play a principal part in rollovers. This could include driving in poor weather conditions. Professional drivers will always match their speed to the weather conditions anyway. Tanker drivers, however, will have to pay particular attention to it, as their vehicles are particularly dangerous in a skid situation. Unexpected circumstances can be another contributing factor in rollover. A momentary lapse of concentration could have devastating effects. There are many different types of tankers on the roads, carrying many different products. Each, though, is subject to the forces of energy that could easily cause them to roll over. Regardless of any safety features fitted by the manufacturer, the deciding factor is always the actions of the driver. If the speed of the vehicle and the angle of the turn are in proportion to the road conditions, the vehicle is far less likely to have a rollover. The effect of a 44-ton vehicle rolling over could be disastrous. If we include the fact that many tankers will be carrying dangerous goods, this could result in a great many fatalities as a result of the rollover. Therefore, professional tanker drivers watch their speed, read the road ahead, pay constant attention and drive carefully. Rollovers are thankfully quite rare, purely as a result of these professional drivers.